Hello class. In this video we're going to talk about factoring, specifically sum and difference of perfect cubes factoring. Um, Before we start, let's define what factoring is. Factoring is basically the breaking down or dividing a number into its factors. Uh, this is the formula for the sum of perfect cubes. This is the formula for the difference of perfect cubes. That's what it says sum and difference. Now, the way we solve them is basically the same, with the exception of the difference in the formula, and we'll see how that looks when we start doing this example. Now, what are the rules for being able to use the sum and difference of perfect cubes? Well, the expression has to be a binomial. So let's look at our example here. It is a binomial, right? And the expression can either be an addition or subtraction because we have a formula for each one. If it's an addition, we use this formula in red, and if it's a subtraction, we use this formula in green. Now, both terms have to be perfect cubes. So this term and this term must be perfect cubes in order to be able to use the sum of perfect cubes. So we have to meet all three of these criteria to be able to do that. Now, how do we solve this particular expression? Well, first of all, right, we have to check to see if there is the greatest common factor between this term and this term. And when we look by inspection, there isn't any. All right. So, and of course, when we went over these rules, we made sure that this was a perfect cube and this was a perfect cube, and it is, right? So the next step is to find the cube root of both a to the third power and b cubed, which is what you see in the formula here. And here's what I mean. So if I have this 27x cubed is represented by the a cubed in the formula. This negative 8y cubed, or just 8y cubed, is represented by b cubed in the formula. Since we have a subtraction, we're going to be using this formula, okay, in green to solve this problem. All right. If it was a plus sign, we'd be using this formula. Okay. So that brings us to step 2. Right. We're on step 2. We're going to find the cube root value of a cubed and b cubed. Now, since a cubed, okay, is represented by 27x cubed, okay, we need to find the value of a because that's what we need in the formula. We don't need a cubed. We need a and we need b in the formula. Okay, so to get the value of a, we have to take the cube root of a cube. Whatever we do on this side, however, we have to do on this side of the equation. So we're also going to take the cube root of 27x cubed. When we do that, that gets rid of our power. So that leaves us with a on this side, and on this side it leaves us with 3x cubed. All right. So that is the value of a. What about b? Well, to get b, the value of b that we're going to use in this formula, right? We need to solve for b cubed. Well, b cubed, okay, is equal to 8y cubed. Okay? So what we're going to do is we're going to take the cube root of b cubed, and once again, whatever we do on this side, we must do on this side. So we're going to do that here. So this side will give us b, and this side will give us 2y. And I made a mistake. It's not cube here. It's just 3. Just x. We take the cube root of x cubed, it's just x. All right? Sorry about that. Now, so here's the value of a. Here's the value of b. All right? Now that we have that, we're going to plug it into our formula. Since this is a subtraction problem, okay, it is representing the difference of perfect cubes. So we're going to be using this formula right here. All right? So here we have, in our solution, we need to have this and this in our solution. So the first parentheses requires me to have a minus b. So a is 3x, b minus b is 2y. So that's what goes in our first parentheses. In our second parentheses, which is represented by these variables here, we need a squared here. So if a is equals to 3x, a squared is basically 3x times 3x to give us 9x squared. Alright? And the formula calls for a plus right here. We put a plus right here. Alright? Plus ab, which is a times b. Well, AB goes here, A times B goes here, so A is 3x times 2y, which is B, that gives us 6, right, xy. Still with me? Alright. Then we've got a plus sign right here in our formula, that's what it calls for, and then it wants a b squared. Since b is equal to 2y, b squared is saying, it's like saying 2y times 2y, or 2y quantity squared, which is going to be 4y squared. Alright? So now that we have that, there is our answer. That is it. Okay? Now, had this been a plus sign right here, we'd go through the same process, except we'd use this formula, okay, to basically solve this problem. That's all the difference, all right? So we're not going to go through that, but this is your answer. By factoring this binomial, we get these two factors here, all right? And this is not factorable anymore, so we're done.